This is K Anand Goud, Assistant Professor, Civil Engineering Department, Institute of Aeronautical Engineering. So today we are going to discuss about the concrete. Okay, in concrete we have different types of concretes: plain cement concrete, reinforced cement concrete, and fiber reinforced concrete. Okay, so in this session we are going to discuss about three types of concretes. So here concrete. So what are the components of concrete here? So here concrete is consisting of three materials. Okay, so the first one is aggregates. Okay, it will contain aggregates as one of the materials, and next cement. Okay, cement is the second ingredient of concrete, and water. Okay, without these materials we are not going to call it as a concrete material. Okay, so if you are coming to aggregates again, so in aggregate we have two types again. First one is fine aggregate and second one is coarse aggregate. So in last class we have already discussed about the aggregates, right? So fine aggregate is nothing but the aggregate which is having the size below 4.75, that is called as a fine aggregate. Okay, and next the aggregate which is having the size more than 4.75 mm. Okay, it is called as a coarse aggregate. Okay, so by combining these all materials we are going to prepare concrete. Okay, so next, what are the uses of concrete? So where we are going to use, okay, what is the main application of this particular concrete? So here concrete is used for the construction of foundations. Okay, for constructing foundations we are going to use concrete material. Okay, and columns. Okay, these are the building components. These all are called as a building components. So for construction of these particular components we are going to use concrete, okay, as a major material. So first one is foundation, next column, beams, okay, next slabs, okay, and other load bearing elements. Okay, other load bearing elements are nothing but like partition walls, okay, floors, slabs. Okay, these all components will be constructed by using concrete only. Okay, so here different types of binding material is used other than cement. Okay, so for binding, okay, in concrete we have cement, aggregates, and water, right? So here cement is nothing but binding material, right? Here cement is a binding material. So instead of cement, here we can use different types of binding materials, that is lime. Okay, one of the binding material is lime here. So here to prepare the lime concrete, okay, to prepare the lime concrete we are going to use lime as a binding material. Okay, and next for preparing asphalt concrete, okay, which is used in the road constructions, okay, or else pavement construction, there we can use bitumen as a binding material. So instead of using cement, okay, instead of using cement in preparing concrete, here we can use lime and as bitumen. Okay, lime is for lime concrete and bitumen is for asphalt concrete. Okay, these are the different types of concretes. Okay, one of the major concretes which are used in the construction. This particular asphalt concrete is used in the road construction. Okay, so next, coming to the grades of concrete. So here whenever you are going to prepare concrete material, here we are going to measure the strength in terms of grade. Okay, so that grade of concrete is nothing but grade of concrete denotes its strength required for construction. Okay, depending upon the structure we need different strengths, right? For commercial buildings, for residential buildings. Okay, depending upon the type of structure the concrete strength should be different. Okay, so if the load is more, then the strength of the concrete should be more to resist the particular higher loads, right? So that particular strength required for concrete construction will be represented by grade of concrete here. Okay, so here strength of mix, okay, whatever the grade we are representing, that will be represented by, or else that will be specified with the names, the following names, that is M5, M10, M15, M20, M25, M30. Okay, so these are the different grades of concrete which represents or which specifies the strength of the concrete. Okay, so here what do you mean by M5 or else M10, M25? So here coming to the detailed note, M is nothing but mix. Okay, it is going to represent the mix. Okay, whatever the mix we are going to prepare, that will be represented with the M. Okay, that is mix. And 10 is nothing but it is a compressive strength of concrete in Newton per mm square, that is millimeter square. Okay, so here 10 represents the compressive strength of the concrete in Newton per millimeter square, and M represents the mix. Okay, that means that particular mix, whatever the mix we have prepared, that mix will be having the strength of 10 Newton per mm square. Okay, so that is the representation of M10. Okay, likewise M15 is nothing but it is a mix Okay, M is nothing but mix, and 15 is nothing but it is the compressive strength. Okay, 15 Newton per mm square. Okay, this is the compressive strength of the particular mix, whatever the mix we have prepared. Okay, so here the units. Okay, here we can represent with the kilonewton per meter square also. Okay, units of this compressive strength is Newton per mm square. Okay, and kilonewton per meter square. Okay, so here 1 Newton per mm square is nothing but 1 megapascal. Okay, we can represent with the megapascal also. So 1 megapascal is nothing but 1 Newton per mm square. Okay, so this is about the grade of the concrete. Okay, and next here for different grades. Okay, now we are going to discuss about the mixed proportion. Mixed proportion is nothing but here the material proportions. Okay, whatever the materials we are taking, like cement, aggregate, and water we are taking, right? So in aggregates, again we have fine aggregate and coarse aggregate, right? So what are the proportions we have to take for each and every grade? Okay, for depending upon the strength, we have divided into different grades, right? So for each strength, for each grade, we have to take different proportions of materials, because every material will be affecting the strength of the concrete, right? So depending upon the materials we have chosen, we have taken for mixing, that will be affecting the ultimate strength of the concrete. So that is why for each and every grade we are going to maintain different types of proportions. Okay, so now coming to the different proportions of different grades of concrete. First one, M5. Okay, for M5 grade concrete, if you need 5 Newton per mm square strength concrete, okay, then we are going with the M5 grade of concrete sample, and for that particular M5 grade we are going to maintain this particular ratio. So in this particular ratio we have three ratios, right? 1 is to 5 is to 10. Okay, so here what do you mean by 1, what is 5, what is 10? So 1 is nothing but cement. Okay, so 1 represents the proportion or else weight of the cement, okay, or else unit of the cement, and 5 is nothing but it is a representation of fine aggregate. Okay, so I'll write this here. Okay, 1 is to 5 is to 10. So here 1 is nothing but cement quantity, and 5 is nothing but fine aggregate quantity. Okay, and next 10 is nothing but coarse aggregate quantity. Okay, so here depending upon the grade of concrete, we are going to take different grades, different mix proportions, and each mix proportions for each grade is different. So coming for M5, okay, coming to M5 grade of concrete, here we are going to take 1 is to 5 is to 10 mix proportion. 1 is nothing but 1 unit of cement. Okay, whatever the unit, it may be kg, it may be grams. Okay, or else it may be in volumes also. Okay, sometimes we are going to take the proportions in volume based, okay, or else batch based. So here 1 is nothing but 1 unit. Okay, 1 unit of cement. If you take 1 unit of cement, we are going to take 5 units of fine aggregate. Okay, and next 10 units of coarse aggregate. Okay, this is what the mixed proportion representations. Okay, likewise, if you observe other material, other grades, so here for M75, it is 1 is to 4 is to 8. That means 1 unit of cement, 4 units of fine aggregate, and 8 units of coarse aggregate. Okay, and here the compressive strength of this particular M5 grade is 5 units, 5 megapascal. That means Newton per mm square, 1 Newton per mm square. Okay, for M7 7.5, it is 7.5 compressive strength, and ratios are 1 is to 4 is to 8. Okay, and next for M10 grade, it is around 1 is to 3 is to 6. Okay, 1 unit of cement, 3 units of fine aggregate, and 6 units of coarse aggregate, and strength of this particular M10 grade is 10. Okay, 10 Newton per mm square. Okay, that is the compressive strength of M10 grade. So likewise, we have different grades, and for each and every grade we have different mixed proportions. Okay, we have to maintain these proportions to get the required strengths, like 15, 20, 25. Okay, if you need 25 Newton per mm square compressive strength, then we are going with the M25 grade mixed proportions. Okay, so this is about the mixed proportions of concrete here. And next, the strength is measured with concrete cube. Okay, how we are going to measure this particular M25 strength or 20 strength? Okay, that will be measured by making concrete cube, and after making that cube or cylinder, we are going with the compressive strength. Okay, so cubes or cylinder made during casting of structural members. Okay, these particular cubes and cylinders, and like before construction of these slabs or columns or floors, we are going to cast one cube or else some cubes or cylinders. Okay, after casting those stuff, cubes or cylinders, then after hardening, okay, after casting, we are going with the curing period, right? Okay, we are going to cure the cubes or cylinder. So after curing period, after getting the particular hardness, then it will be cured for 28 days, and after 28 days the compressive strength test will be conducted on that particular cube. Okay, first initially we are going to mix the sample and we are going to make cubes or cylinders. Okay, so after casting this particular cubes or cylinders, we are going to place it for a curing. Okay, after curing it for 28 days. Okay, after curing it for 28 days, next we are going to conduct compressive strength on that particular cube, okay, or a cylinder. Then after that we are going to know the strength of the concrete. It may be 25, it may be 20, or it may be 15. Okay, likewise we are going to conduct the compressive strength after casting the cubes, okay, before construction of major components like columns, walls, foundations. Okay, so that is about your normal concrete basics. Coming to the fiber reinforced concrete, so here if you observe the plain cement concrete, it is consisting of only cement, fine aggregate, coarse aggregate, and water, right? So here the concrete cube, the plain concrete, is strong in compression. That means it can take compressive loads majorly. Okay, it can take compressive loads majorly. Okay, but if you apply tensile forces on the concrete, it cannot take. Okay, it is very weak in tension. So that is why whenever you are going to cast concrete, it will be strong in compression forces. Okay, when you apply the compressive forces, it can bear up to higher forces also, higher loads also. But if you apply this tensile load, okay, the direction will be like this. If you apply this tensile loads on the concrete specimen, okay, then it is going to fail as soon as possible. Okay, so that is why to increase this particular tensile strength, we are going to add some fibers in the concrete. That is in terms of reinforcement. Okay, it may be steel or it may be fibers, other fibers, okay, polymer fibers, okay, whatever the type of fiber. Okay, that particular fibers are used in the concrete to increase the tensile strength. Okay, because concrete is weak in tensile nature, right? So that is why we are going to add, because the fibers, whatever the fibers we are using, that will be strong in tension. Okay, if you observe the tensile steel fibers, okay, if you apply compressive forces, it will fail, okay, at some point. But if you apply tension forces on the steel rod, it is not going to fail suddenly. Okay, it is not going to fail suddenly. It is going to take more loads as compressive loads in the concrete. Okay, so that is why we are going to add some fibers in the concrete. So plain cement concrete possesses very low tensile strength, okay, limited ductility, and little resistance to cracking. Okay, so when you apply compressive force, tensile forces, okay, when you get some cracks, it is not going to resist majorly. Okay, so that is why this particular plain cement concrete will be weak in tension force and ductility. Okay, ductility also very less for normal plain concrete. And next, resistance to cracking. Okay, cracking resistance is also very low for plain cement concrete. So that is why we are going to add this particular fibers. So internal micro cracks, okay, in concrete we will be getting some internal micro cracks when you apply the force. Okay, like around the cracks, okay, around the surface of the crack, we may get some small micro cracks. Okay, so to avoid that, also we can use fibers. Okay, so it has been recognized that addition of small closely spaced, okay, addition of small closely placed fibers to concrete would act as a crack arrestor. Suppose if you get any crack inside the concrete member, if you add fibers, okay, if you add fibers like this, then the crack which is developed here will not propagate into this particular area, because here we have added one fiber. Okay, that particular crack will be resisted by this particular fibers here. So that is why we are going to use the fibers to arrest the cracks. Okay, that is one of the benefits of fibers. Okay, fibers are going to resist the crack, okay, crack propagation. Okay, so or else it is going to act as a crack arrestor. Okay, and would substantially improve its properties. Okay, if you avoid the concrete, crack propagation, then automatically the strength will be increased. I mean, the failure will be decreased. right? So this type of concrete is known as fiber reinforced concrete. So to avoid that particular crack propagation, okay, whatever the cracks are developing, that will be stopped, okay, that will be avoided by using this particular fibers, okay. The placement will be different for each and every structure. So if you add these fibers, we can stop the crack propagation, okay, so that we can improve the strength of the concretes. So these particular cracks which are added with the fibers are called as a fiber reinforced concrete, okay. So here fiber reinforced concrete can be defined as a composite material, okay. Composite material is nothing but it will consist of two or more materials. Like if you coming to the concrete materials, here we have cement, okay, aggregates. In aggregates again fine and coarse aggregate, okay, and next water and fibers, okay. So here it is having four materials, okay. So here fiber reinforced concrete is defined as the composite material consisting of mixtures of cement, okay, consisting of mixtures of cement, mortar or concrete, okay. Sometimes it may have cement or it may have some other binding materials also. So like lime, okay, if you mix lime with fine aggregate, then also it is called as a mortar, okay. That is why here I have mentioned here mortar or concrete separately, okay, cement separately and mortar separately, okay. Cement is not a compulsory ingredient in the concrete, okay. It is one of the ingredients we can choose, okay. So mortar, concrete and discontinuous, discrete and uniformly disposed suitable fibers, okay. This particular fiber reinforced concrete is going to consist of this all the materials: cement, mortar or concrete and discontinuous or uniformly disposed suitable fibers, okay. This will be called as a fiber reinforced concrete, okay. This particular concrete is called as a fiber reinforced concrete here, okay. So now coming to the different fibers of concrete, here these are the different fibers. Coming to the steel fibers, okay. So this is hooked end, okay. In steel fibers also we have different shapes. We have fibers with different shapes, okay. So here first one is hooked end, okay. If you observe the ends of this particular fibers, it will be like a hook, okay. Next, twisted fibers, okay. If you observe the texture, okay, surface of this particular fiber, it will be twisted, okay. And next, straight fibers, okay, straight steel fibers, okay. These all fibers we can use in the concrete making, that is fiber reinforced concrete, okay. And next one, synthetic fibers, okay, that is processed, okay. Polypropylene, because this is one of the plastic materials, okay. With that also we can use the fibers, okay. And next, glass fibers, okay. This glass fibers also we can use for making the fiber reinforced concrete, okay. And next one, carbon fibers, okay. Carbon fibers also we can use in the preparation of fiber reinforced concrete, okay. These are the different types of fibers which we can use for preparing the fiber reinforced concrete, okay. And next, coming to the glass fibers, okay. These are the glass fibers which are manufactured in the company like this, they are going to manufacture, okay. So now coming to the fibers, okay. What are fibers, okay? Fibers will be having different properties, okay. So each type of fiber has its own properties and limitations, okay. So here each type of fibers has its own properties and limitations, okay. Every type of fiber will be having different properties, like depending upon the material composition, okay, and their strength, based upon their strength, okay, the properties will be different, and limitations, like as I have said already, the properties and composition will be limited to some applications only. So each and every fiber will be having different limitations and properties, okay. Based upon those limitations and properties, we are going to apply those fibers in a specific functions, okay. So some of the fibers that could be used are steel fibers, okay. Some of the examples are steel fibers and polypropylene fibers, nylon fibers and asbestos fibers, coir, rubber coir fibers, and glass and carbon fibers, okay. So these are the different types of fibers which we can use in a preparation of fiber reinforced concrete, okay. And next, fiber is a small piece of reinforcing material. So here what do you mean by fiber, okay? It will be like this, right? So it is a reinforcing material. Reinforcing material is nothing but it is a reinforcement. What do you mean by reinforcement? it is a material which is improving the properties. Okay, reinforcement is nothing but we are going to improve the properties, we are going to improve the strength of the existing structures, or else whatever the material, whatever the component is there, for that particular material component we are going to increase the strength by adding these fibers. Okay, that process is nothing but reinforcement. So here reinforcing material, so these all fibers, okay, carbon fiber, glass fiber, steel fibers are acting as a reinforcing material for concrete. Okay, that means here we are going to improve the strength, what we are going to increase by using fibers, we are going to increase tensile strength, right? So this tensile strength we are going to increase by adding fibers. Okay, so that is why these all fibers are called as a reinforcing materials. Okay, it may be in the fiber, I mean reinforcing material is not only fibers, might it may be in different shapes. Okay, it may be circular, it may be square, okay, whatever the shape of the object material. Okay, but that material, whatever the material we are using, that is going to improve the properties, then it is called as a reinforcing material. So here we are using fibers as a reinforcing material to improve the tensile properties of the concrete. Okay, so that is what about the fibers. Okay, so they can be circular or flat. Okay, the shape of the particular fibers will be in a circular shape, or else it will be in a flat. Okay, it may be in a square shape also, it may be in a, this is the top view. Okay, it may be in a circular shape, or it may be in a square shape. Okay, depending upon our requirement. Okay, so flat, the fiber is often described by a convenient parameter called aspect ratio. So here the fibers will be described and defined by using aspect ratio. So aspect ratio is nothing but it is a length to width ratio. Okay, so this is your fiber, right, and this is the top view. So this length to this width ratio is called as a aspect ratio. Okay, so here that typical aspect ratio of different fibers should be in the range of 30 to 150. Okay, so the fibers range we have to maintain the fiber range, whatever the fiber you are using in the concrete, that aspect ratio is nothing but length to width ratio, right? So this ratio should be in between 30 to 150. Okay, so this particular ratio we have to maintain. Okay, that is what about the fiber aspect ratio. Okay, and next, steel fibers is one of the most commonly used fibers. Okay, this is in particular, I mean in concrete particularly we are going to use steel fibers majorly. Okay, so generally round fibers are used. Okay, you have already observed in the construction site already. So reinforcing steel will be used. Okay, so reinforcing steel will be used as a fibers in the concrete to improve the tensile properties. Okay, so next, use of steel fibers makes significant improvements in flexural, impact and fatigue strength of the concrete. So these particular steel fibers are going to improve the flexural strength, impact strength and fatigue strength of the concretes. Okay, this is the benefit of the steel fibers. And one of the example I'll show you, if you use steel fibers, what happens. So this is your concrete beam which is made up of with the concrete material. Okay, so here we have not used any reinforcement material. Okay, to cast this particular specimen they did not use any reinforcement. So here if you apply the compressive force, okay, at the top, if you apply the compressive force, it is going to crack. Okay, because here we are applying force from the top, so it is getting crack. Okay, that crack is developing from the bottom. Okay, because if this has to bend, so if you suppose this is the initial position of the beam, and if you apply the force and here we are giving supports, so it is going to bend like this, right? It is going to bend like this. So whenever it is bending like this, here the this material is coming towards the center. See, okay, this here the compressive forces will be developed, and if you observe this bottom portion, if it has to move in sideways, then what is happening here? It is the material is moving like this away from the center. That means here the tensile force is developing. Okay, at the top the compressive force is developing because that material is moving towards the center, and at the bottom of the beam the material is moving away from the center. So that means if the material is moving away, means here the tensile force is developing here, right? So here the fibers or else the material, the particles will be moving away from the center point, right? So that is why, okay, if you apply the compressive forces here, it can bear. That is why the failure is not developing from the top. Okay, what I have said, concrete is weak, concrete is strong in compression. So here at the top portion, the compressive forces are developing. That is why the failure is not coming from the, or else the failure is not developing from the top. Okay, if you see here, the crack is developing from the bottom itself, right? So because here the tension forces are developing. That means due to this tension forces, the crack is developing from this point. Okay, this point to this point. So that is why the crack, the beam is failing because of this tension force at the bottom of the beam. Okay, suppose if you place any reinforcement before casting, okay, like this, if you place steel reinforcement in the mold and if you cast the beam, okay, then if you then after casting this particular reinforcement beam, concrete beam, then if you apply the compressive forces, okay, if you apply the compressive forces, then see here what is happening here. It is not going to fail suddenly because here we are getting some cracks only. Okay, that means here due to this particular reinforcement, okay, that is going to take the loads, okay, up to some point. Okay, so up to some point it is going to take some loads. That is why it is not going to crack suddenly, okay, as we have seen in the first pick. So here the crack is developed at one point itself. Okay, after application of maximum load, the crack is developed, but in the later peak here, the crack is not developing continuously, suddenly. So here, because of this particular reinforcement bar, okay, so it is going to take tensile loads also. We may get the cracks, but that beam is not failing completely. Okay, that is what the benefit by using reinforcement. Okay, so this is the one of the failures of the, after applying a lot of higher load, very high loads, then it is going to fail like this. Okay, that means if you compare without plain cement concrete beam and reinforced cement concrete beam, so here it is going to take less loads because here no fiber is added in the PCC, okay, plain cement concrete. But if you observe this reinforced cement concrete, it is going to take more loads compared to plain cement concrete. Okay, that is what about your plain fiber reinforced concrete, steel fiber reinforced concrete. So coming to the glass fiber reinforced concrete, here glass fiber is a recent introduction in making fiber concrete. Okay, here after using steel fibers, here we have got one development by using glass fiber. Okay, recently they are using glass fibers also as a reinforcement material. Okay, so it has very high tensile strength, around 1020 to 4080 Newton per mm square compared to reinforced steel concrete. Here it is having this much amount of tensile strength. Okay, so next, up to 5% glass fiber is added to the total volume of cement. So here we are not going to take the volume of concrete. So here we are going to take the volume of cement. Okay, suppose we are making 100 grams of concrete. So in that 100 grams of concrete, we may have only 20 grams of cement. Okay, we are not going to use completely cement in 100 grams of concrete. So we may have 20 grams of cement powder. So out of 20 grams, we are going to take 5% of fibers, glass fibers. Okay, so out of this particular cement weight, okay, so up to 5% glass fiber is added to the total volume of cement. Okay, by taking volume of cement, we are going to take the glass fibers, not based upon the concrete volume. Okay, so next, glass fibers are available in the form of continuous rovings. Okay, these are the rovings. Okay, in this forms the glass fibers are available. Okay, or else chopped strand mats. Okay, these are the strand mats which are used in the construction also. Okay, so these are all fibers, single individual fibers also we can use in the concrete directly. Okay, and next, wool. As a wool also we are going to use this particular glass fibers in the construction, and ropes and woven fabrics. Okay, so these are the different types of other products we are going to make by using glass fibers. Okay, this is about your today's session, concretes. Okay, different types of concretes. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.